Alright, episode 3. Now, this is a continuation of using the compound interest formula, but this idea that I'm about to show you with this formula can also be used for these other two formulas that are remaining in this homework. But read the situation very carefully. Part of the difficulties in word problems is trying to figure out what is given and what you are asked to find. So just read carefully. In the previous problem in episode 2, now the numbers have changed because I've already answered the problem, but if you go back and look at that video, this was a 14,000 and that was a 4%, and I think that was 7 years. But regardless, this is asking us to find the balance in the account if you invested money for a certain term at a certain rate with quarterly compounding. If you fast forward to this question, this is asking how much must be deposited today. So if you're going to invest money, how much would you need to invest today? So how much would you have in your pocket that you could put into an account? That would be your p-value, right? Principal is the initial amount. So how much, that's what you're looking for in this example. You're actually going to be looking for this p. You're not given p. You have to find p. Alright, so how much must be deposited today into the following account in order to have 7,000? So you want 7,000 by the end of this term. So that is what you want your accumulated final value to be. So that's I think I said 7,000, but that's 70,000. You want A to be 70,000, and then of course if you keep reading, 6 years, you're using this. You need 70,000 for a down payment on a house. So it's not asking you anything about a mortgage, so we're not quite there yet. You're just asked, hey, if I want to buy a house in 6 years, and in order to buy that house I need to have $70,000 as a down payment, how much do I need to invest right now in order to make this happen? And it says assume no additional deposits. So you're going to make the initial principal deposit and you're going to let it sit. You're not going to touch it. You're not going to take money out. You're not going to add any more money out of your pocket. You're just going to put down a certain amount, let it grow for 6 years, and it's in an account with annual compounding. So annual compounding, annual would be 1 time per year. So this is not simple interest. This is annual compounding, that keyword compounding. So your N is going to be 1. Your rate is 6%, and you want to have 70,000 by the end of your investment. You're looking for P. So plug everything in based off the situation. So A, you want to be 70,000. Alright, make sure you don't accidentally write 7,000. Equals P is what you're looking for. 1 plus your rate is 6%. Again, remember, express that as a decimal. Divided by N, annual compounding would be 1 compound per year. If that said semi-annual compounding, your N would be 2. Monthly compounding, N would be 12, and so on. But in this case, annual compounding. And then you're going to raise this to the power of N times Y. Your N is 1, your Y is your years, and so we're going to invest for 6 years. So 1 times 6. And now this is calculated a little differently when you compare this to episode 2. So this time you're looking for P, not A. You still want to take that right side and follow your order of operations. So go ahead and find out what the inside is. Now I know anything divided by 1 is itself. So I know this inside is going to be 1 plus 0.06, which is 1.06. But if that N were anything other than a 1, then go ahead and type this in the way you did in episode 2, where we first initially discussed compounding interest. Type it in 1.06. Let's write that down. So P times 1.06. Now again, remember, these two numbers multiplied in the exponent. 1 times 6 is 6, so we can go ahead and say that that's raised to the 6th power. Alright? And so now, if you go back to the very end of episode 2, I mentioned, and this also mentions, do not round until the final answer, and then round to the nearest cent. Okay, but we have to raise that 1.06 to the 6th power. So if we do that, we get this. Okay? Definitely do not round that anywhere to like 1.42 or 1.419. Do not round it. We're not supposed to round it at all. But in order to continue with this problem, we want to solve this equation. We have to find out what P equals. So what I would suggest doing is take what the calculator's showing you and write down everything. Even though that's actually a rounded value, it's a lot less significantly rounded if we were to just round it to 1.42 or something like that. So show your steps. 70,000 equals P. 1.06 to the 6th power is approximately this, but I don't want to cut off any of these numbers. I actually want to write everything I see. And so I'm going to put that down here and make sure I do not make a mistake writing this down. One small mistake can cost me a lot of money in this case, because this is a money problem. So again, even though that is approximated, it's not as approximated. Ultimately, it shouldn't affect our answer. Alright, so write down what the calculator shows you and be very careful. You know, if you flip that 9 and that 1, you might get the answer correct. So make sure you're very, very careful. And now the goal is, this is just a basic linear equation. You want to find P. You want to find what number can you multiply to this decimal and get 70,000. One way you could do that is to divide. So if I divide by this decimal, again, making sure I type it down or write it down correctly, I want to divide both sides by that. And what's happening is, when you divide by that decimal on the right side, anything divided by itself is 1. And so on the right side, you're left with P, and that's the goal. The goal was to find that P value. So now you come to your calculator and you take 70,000. Be very careful not to type 7,000, and you divide it by this. Now, if you want, I suggest doing it like I'm showing you here, but if you're very familiar with your calculator and you know how to use parentheses properly, then you could do this in a little less work. But to be careful, I would highly suggest doing it this way. Round that to the nearest cent. So you're going to have to invest $49,347.24 in order to have 70,000 by the end of that 6-year period. Alright, so let's type that in. Let's see if we got it correct. 49,347.24. Nice work. We got it. Alright, so it's a little more work, but as long as you're very careful, hopefully it's not difficult work. Now, I do think that it can get complicated, especially as you work with different formulas, but if you're just very careful with how you show your work, and don't try to hit a home run and do it in one step. Break it down and solve for your P very carefully in this case. Alright, you might be asked sometimes to find a different letter, P in such and such, but for now we're going to just finding that P value. Now, like I said, just take note of this. 23784. Alright, let's see, because again I rounded that. Let's see what it is exactly if I did not round that. This is how you would have to do that. If you take 70,000 and you divide it by this, you have to be very careful. Alright, so divide by parentheses 1.06 raised to the 6th power. And you get the same thing. Alright. Sometimes that might be a decimal way out here that's off, but since we're rounded to the nearest cent, notice no matter which way you do it, you'll still get 24 cents. Alright, but still be careful. I do suggest doing it this way and writing down those long decimals very carefully, because if you look at the formula sheet, some of these formulas are a lot to put it lightly. So it's very, very important to practice, and I think this is the best way to practice these formulas. So for now, that is all I can record. I will record episode 4 as soon as possible, and that will be an episode that is using the savings plan formula. So look for that soon, but I hope these first 3 episodes did help you, and talk to you soon.